Okay, so these are page 2 of the notes for section 4.3 dealing with logarithmic functions. If you have not yet attempted page 2 of these notes, then stop this video and try to work the whole page and see if you can kind of develop the rules on your own, and then we're going to use those rules on the next page. All right, so pause the video and do page 2 and then come back to it. All right, so trying to develop some rules, 3 different rules, and so these examples are going to help us visualize what's going on with these rules. So again, we're on page 2 here. So log base 4 of 16. Remember, this whole thing is equal to the value you'd have to raise the base to make it equal to the argument. So I think everyone can see that that would end up being 2, right? 4 to the 2 is 16. So this whole thing is equal to the value you got to raise the base to make it equal to the argument. So 4 raised to the second power is 16. So this whole thing can be replaced with a 2. And then log base 4 of 4, that's just 1. So the answer to this thing, this is just equal to 3. All right, now let's look at this one. So log base 4 of 16 times 4. So the argument, really important that you have parentheses here. Logarithms fit in with, as far as PEMDAS in order of operations, fit in with exponents. So if you don't want to take log base 4 of 16 and then take that result and multiply it by 4, you need parentheses around there. Okay, so we could simplify this to log base 4 and multiply that together, 64. And then, well, 4 raised to what power is 64? So that's log base, that's just going to be equal to 3. Okay, now, the whole point that we want to visualize here is that these are the same. And it's not a coincidence that these gave us the same results. Look at the pattern here and see what's going on. How could we go from here to here, right? These things seem to be equal to each other. So it seems like there could be a rule. All right, let's look at another set of examples and see if we can kind of see the rule again. So log base 3 of 27, that's just 3. And then 3 raised to what power is 1 over 9? So if it was 9, it would be 2, but it's 1 over 9, so it's negative 2. So this is just equal to 1. All right. Log base 3 of 27 over 9. Well, 27 over 9 could be simplified to just 3. So this could be log base 3 of 3. And we know that that's 1. So again, these are equal, not a coincidence. What are we doing to this to get this, right? Like how can we go between these two? And so hopefully using how we can see these two are related and these two are related, we can come up with a rule. All right, and that rule is log base b, when we're adding 2 logs with the same base, it's the same as multiplying 1 log with the product of those 2 arguments. Okay? All right, and so that will be called the product rule. All right, let's move on. Let's see what's going on here. So what's log base 3 of 27? That's 3 minus log base 3 of 2, log base 3 of 9, that's 2. And so this is just equal to 1. And then log base 3 of 27 over 9, well, we saw that that's log base 3 of 3, which is 1. Sorry, that was my phone. And so log base 3 of 3 is 1. Okay. So what do you notice about these, right? So look at these arguments this time, and look at these arguments and see what the relationship is between them. All right, and so what's that rule going to be? So the difference of 2 logs, again, the same base, what can we do? This is log base b of the ratio, or the quotient the division of these two things. The positive one, the one in front, is on top, and m is on the bottom. Okay, and this will be referred to as the quotient rule. All right, let's look at this last set. All right, 3 times log base 2 of 4. So log base 2 of 4, that's just 2. So this is equal to 3 times 2, which is 6. And now let's look at log base 2 of 4 cubed. 4 cubed, that's what? 64, right? So we could say that's log base 2 of 64. And then 2 raised to what power is 64? Well, that's just 6. And again, not a coincidence that these are equal to each other. Think about what's going on here. How did we go from here to here? All right, let's check. Let's try some more. This one's kind of a combination of several other things, I think. But, okay, so 2 times log base 3 of 2. So that's 2 times 2 plus 3 times log base 3 of 3. That's just 1. And so that's 4 plus 3. Well, that's going to be 7. All right, let's look what this is what's going on here. So we have log base log base 3 of 9 squared times 3 cubed. So that's the same as log base 3 of, if we want, 81 times 27. But I think it would be best if we think of these things together as 3 raised to some power. So take that argument and write it as 3 to some power. So this is 3 to the 4th. This is 3 to the 3rd. So probably best, rather than simplifying those like we did here, probably best to think of this as log base 3 of 3 to the 7th. And then, of course, we know that's just 7. And again, not a coincidence that those are the same. What are we doing with these numbers to get these numbers? Actually, we're doing a couple things here, right? We're using the product rule to combine these. But notice up here in the product rule, this has to be a 1 and this has to be a 1. You can't combine them if there's coefficients out in front of those logs. What we're going to do is use this rule to combine those, to get rid of that coefficient. So let's concentrate on these two. What's happening with this p? The p out in front can be put up. Now, it can be put up as the exponent on not the logarithm, but on the argument. So this will be equal to log, the same base b, of n to the p. Now, this is not equal to log base b of n and the argument being raised to the p. So be careful. It's not that. This exponent is on just the argument. It's not the exponent on the log, the whole thing. Okay? Now, what's going on here is we're bringing the 2 up on top of the 9. We're bringing the 3 up on top of the 3. Well, not on top of, but, you know, the exponent. So it's going to bring this 2 up and make that 9 squared. Bring this 3 up and make that 3 cubed, or 27. And then we're using the product rule. So really, we're using two things to go from here to there. We're using the product rule, the power rule first to get rid of the coefficients, make those up on top. Then once we've done that, now we can use the product rule to put those together. Okay, so we're using kind of two rules there. All right, and so that's page 2. That takes us now to page 3, where we can sort of write our rules out. All right, so page 3 then, the product rule. So the product rule is really just what we had on the other page. It's going to be log base b of n plus log base b of m is equal to log base b of the product of n times m. All right, now you have to be careful. You can't say the product of the two logs. right? That is not what's going on here, right? It's the product of the arguments, not products of the log. So we don't know, like this doesn't give us anything. We can't really say like, oh, what's the product? Some students tend to say, well, I can replace this with a multiplication, then I'll put a plus in here, and that doesn't work. So, all right. So now let's use this idea. So we're given, we're trying to do this kind of without a calculator. So log base 3 of 5. We're given what that is. It's approximately 1.5. It's probably a pretty bad estimate, but let's just use it. The real estimate would have like 4 or 5 decimal places, and to do this without a calculator is kind of annoying. So let's just assume that log base 3 of 5 is about 1.5. Okay. So now how can we use that to evaluate log base 3 of 45? So we want to take this 45, and that 45 is like a product of two things. This rule don't have to start with addition, right, of two logs. We could have the log of a product of two things, and we could break them up. So this rule goes both ways. You can start with the log base 3 of a product, like is what we have here, right? 45 could be written as a couple different things. We want to think of it, though. We don't want to say like 3 and 15 because we don't know what log base 3 of 15 is. We want to use things that we know. So we could take this and write it as log base 3 of 5 times 9. Now you might say, oh, we don't know what log base 3 of 9 is. We were only given log base 3 of 5, but we know what log base 3 of 9 is. We were doing that on the other page. So using this rule in that direction, right, we have sort of this side, we can break it up using this. So that's log base 3 of 5 plus log base 3 of 9. Log base 3 of 5 is approximately 1.5. So I could take this and just replace it with 1.5. And then log base 3 of 9, well, that's just 2. So this is approximately equal to 3.5. Now, if we were able to get a calculator to do this for us, we'd see that's probably a pretty bad estimate. But for now, that's good enough for us. All right, now let's try this one. So how could we write this? We could write this as log base 3 of 5 times 5. And so that's log base 3 of 5 plus log base 3 of 5. Or we could write it as 2. You could write it as, there's 2 of them, right? So we could say 2 times log base 3 of 5. Now, of course, here we could say, oh, this is 1.5 plus 1.5, and so that's approximately equal to 3. But we know that's wrong because log base 3 of 27 is 3. Remember, this is an estimate, and that's a probably pretty bad estimate. So once we get more complicated things, you're going to see like, oh, log base 3 of 27 is 3. So how are we getting log base 3 of 25 is 3? It's because that's a pretty bad estimate. Okay, I just wanted to keep it simple. All right, but here we could take this a step further and look at our power rule, right? This 2 could go up here. So instead of saying, I could take that 2 that was up here and bring it down in front using my power rule. Okay, and so it's 2 times log base 3 of 5. So 2 times 1.5, which is the same as 2 1.5s added up. And again, that's a pretty bad estimate, but it's 3. Okay. The next one, quotient rule. All right, so this is log base b of n minus log base b of m, and that's equal to 1 log of the quotient, log base b of n over m. Okay, and that's the quotient rule. So let's use that. So this time now I've given you, instead of giving an estimate, I gave you a letter. So log base 4 of 5 is just going to be A. Log base 4 of 15 is going to be B. So we're going to rewrite this in terms of A's and B's. Okay. So it's quotient, it looks like. So I can immediately, again, work in reverse. These rules go both directions. Here I'm going to start with this quotient, and I'm going to write it as a difference. So this will be log base 4 of 5 minus log base 4 of 16. So log base 4 of 5, well, that's just a, so I can write this as a minus log base 4 of 16. They didn't give us that, they gave us 15, but we know what log base 4 of 16 is. That's just 2. Okay, so you'll have other things other than just a's and b's in this, but all right, so log base 4 of 3. Okay, well, we don't have 3, but could we make 3 up? Yeah, that's the same as log base 4 of 15 over 5, isn't it? To get my 3. All right, so we have to use what we have here. So we have to use log base 4 of 5, log base 4 of 15, or we know what log base 4 of 4 is. We know that's 1, right? We know what log base 4 of 1/4 is, right? I mean, so we know what some things. We don't have to be given everything, but we're given the argument of 5 and 15, but we can also do 16. We can also do, other multiples of 4 that would be able to simplify without having to be given an actual value for them. All right, so this becomes log base 4 of 15 minus log base 4 of 5. And so that's just b minus a. b minus a. All right, log base 4 of 500 now. Log base 4 of 500. Try that one. All right, and so we have to come up with 500, and we have to use 5s and 15s to come up with 500. All right, so let's say maybe we could say that's log, and maybe this may not be quotient rule. This might be other stuff, right? So log base 4 of, we could say 5 times 100, or we could say what? 500, we could do 5 squared, which is 25. And 5 squared is 25. 25 goes into 500, what? So 25 goes into 100 4 times, and there's 5 of them, so 20. All right, but there's another 5 in there too, so really we could do what? I think we could do 5 cubed times 4. And we can sort of think about, okay, let's break these up. So in this case, we're not using the quotient rule, we're using the product rule. Log base 4 of 5 cubed times, plus log base 4 of 4. Sorry, there's a glare on my paper. I can't really see what I'm writing here. We can use the power rule to bring that down in front. We saw that in the other page. We know this is just 1. So this will be 3. Don't try to write the answer in this stage. You want to bring this down, because what happens is people write this as what? A cubed, and it's not. Because remember, it's not the whole logarithm that's being raised to the third power, so it wouldn't be a cubed. It would be 3 out in front times log base 4 of 5. So it's going to be not a cubed, but 3a, right? And then, of course, this would all be 1. So we have 3a plus 1 is our answer there. And that's a common mistake. People will try to go from this step down to this step, and they'll make a mistake because they'll say, oh, that's a. Oh, and look, it's getting cubed, and it's not. The 5 is getting cubed, not the whole logarithm. So bring the 3 down in front. So 3 times log base 4 of 5. Log base 4 of 5 is just a. So this is 3a, not a cubed. Common mistake with that kind of thing. Okay. All right, the power property. So the power, I want to write it in the same way we had it on the other sheet. Let me find my other sheet here. I think it started with the p out in front. So p log base b of n is equal to log base b of n raised to the p. Now remember, this is not the same as log base b of n raised to the p. It's not equal to that. All right, so it's not a cubed like we saw over here. All right, so let's try some of these then. Well, we sort of already, I'm not really giving you another example for the power property. We've kind of already used that here. So let's look at some examples. Use the above properties. So we're using all three, the product rule, the quotient rule, and the power rule. Product, quotient, and power rule, and use those to answer the following 8 questions. All right, so what we want to do is simplify this. All right, we can't use the quotient rule on this until we make these coefficients 1. So notice we don't write it in here, but this has got to be a 1, and this has got to be a 1 if you're going to take these things and combine them. All right, so we can't have anything out in front. First thing we want to do is get rid of those using our power rule. Log base 3 of 6 squared minus log base 3 of 16 to the 1/4. All right, and so now it's a subtraction, so we're doing quotient, so we can write this as log base 3 of the quotient of these two things. So that's going to be 36, 6 squared, 36, divided by, and then this is 16 to the 1/4 power, so that's just going to be 2. All right, and so then let's simplify that. Log base 3 of 18. Okay? I would say pause the video and then try some of these on your own. And then if you need to see them, then you can start the video back up again. But like try some of these on your own. Pause this video now, and I'm just going to plow through them. But hopefully you will do them. Pause the video and do them all on your own first. All right, log base 4 of z plus log base 10 of z plus log base 10 of z plus 3. That's going to be the product rule. So this is the same as log base 10 of, and then we could say z squared plus 3z. I went ahead and distributed the z. I'm multiplying these two arguments together. So I went ahead and simplified it. All right, next one. Log base 6 of x plus log base 6 of 9. That's going to be log base 6 of 9x. Now sometimes in the book they do this as well. They don't often put the stuff in parentheses. They just leave a gap kind of between, so you kind of know that it's the whole thing is the argument. I tend to put parentheses because order of operation without the parentheses kind of makes it look like it should be log base 6 of 9 times x afterwards, right? So without the parentheses, I kind of feel like it would be this times x, and that's not what we mean. Okay, so your arguments, if it's just a number, like here up at 18, it's just a number, or it's just a variable. But if it's multiple things, I kind of feel like you should put parentheses around it. You'll find our book does not do that. Okay, number 6. I'm going to get rid of these coefficients before I can combine these using my product rule. So this is going to be log base 7 of 8 to the 2/3 power plus log base 7 of 8 to the 1/3. Now in this case, actually, we could just have combined these, not combined like terms, right? This is like saying 2/3 x plus 1/3 x. That's just 3/3 x. So we could, you know, we're practicing the exponents here, the exponent rule, the power rule. But you could have just said, oh, isn't that just log base 4 of it, log base 7 of 8? And yeah, you could do that. But let's go ahead and practice this. 8 raised to the 2/3. So that's going to be 8. The cube root of 8 is 2. Squared is 4. So this is log base 7 of 4 plus log base 7 of 8 raised to the 1/3 power is 2. Now using our product rule, we can say log base 7 of 4 times 2, which is 8. But again, we could have gotten that by just saying, oh, isn't this just, using this kind of idea, isn't this just one of them? There's 2/3 of this thing, there's 1/3 of those things. That's just one of those things. So we could have just kind of used simple algebra. It's not algebra, but simplifying rules from algebra to get to this answer. But again, we're practicing exponents there. All right, here, again, we want to get rid of the exponents. These aren't the same, so we couldn't just combine these like we could have up there. So we're going to write this as log base 3 of 16 to the 1/4 plus log base 3 of 64 to the 1/3. And remember, maybe I didn't emphasize it enough, but with all of these problems, the bases have to be the same, of course, in order to combine these using the product rule, the quotient rule. You know, the bases have to be the same. All right, and so now we can simplify that and simplify that. It's plus, so it's going to be the product log base 3 of 16 to the 1/4, that's 2, times 64 to the 1/3, that's 4. And so this is just simply log base 3 of 8. All right, this one over here. Log base 8 of the product of, I'm going to write it first kind of not foiled out, so you can kind of see, n plus 4. Right? So it's the product of those binomials, which is now our argument. And so this is log base 8 of, and then let's write it out. This will be what? N squared plus n minus 12, all in parentheses there. All right, and this one here. Now this one's a little different. We're not just rewriting it, we're trying to solve these. So these are got variables in them, so let's actually solve this. This is an equation. So we can combine the left-hand side, it's subtraction, so we're going to have the quotient rule. We have log base 16 of 9x plus 5 over x squared minus 1, and that's equal to 1/2. All right, so we want, like, we don't know what to do, so let's convert it. Let's convert this from a logarithmic equation. Remember, that's the log base 16 of this whole argument is equal to 1/2. So let's convert this logarithmic equation back into an exponential equation. So that means 16 to the 1/2 power, so 16 to the 1/2 power equals the argument 9x plus 5 over x squared minus 1. 16 to the 1/2 power, that's 4. And so now we can do, you know, think of this as a ratio, a proportion, you know, 4 over 1, so do the cross product. So we get 4x squared minus 4 equals 9x plus 5. And now we have a quadratic equation we need to solve. And so what we want to do is take everything to the same side. We have 4x squared minus 9x, bring the 5 over, that's going to be negative 9 equals 0. And so let's see if that factors. And so you might try 2x and 2x. Can't be 3 and 3 because then that's just not going to give us. That would be the conjugates, right? And so when we multiply conjugates, that would cancel out, right? Because it's going to be negative and positive. So it would have to be 9 and 1. It can't be 3 and 3 because then, again, we would have conjugates. That's not going to work. This doesn't seem to work, right? This is 18 minus 2. That's not. So 2x and 2x doesn't seem to work. So let's try 4x and 1x, or just x. And let's see what happens with that. So we have, that's way too big, right? We don't want to do that. What if we did with this, we do the 3 and the 3. 3 and 3. And so we have what? We have 12 and we have 3. So that has a difference of 9. So that's good. We want this to be negative, the negative 12x, and the positive 3x. That gives us the center term that we're looking for. So equals 0. And so we set each of these equal to 0. So what are our two solutions? We get x is equal to negative 3/4 and x is equal to 3. Now, we have to think about this and see, okay, are these both valid answers? So when we, this x is positive, generally that's going to be good, but when we plug the x back in, got to make sure that we don't have negative arguments. If either one of these x values makes either one of those arguments negative, then we have to eliminate it. It's not part of our domain. And so 3 seems like it would work. 3 in here would make it 9. 9 minus 1, that's 8. That's good. And that would make this positive. So we don't have a problem with the x is equal to 3. But negative 3/4, let's see what happens when we do that. That's going to be negative 27/4, right? So that's going to be bad. Negative 27/4 plus 20/4, that's going to be negative. So we have to eliminate this as a possible answer because it might be a solution to this equation, but it's not a solution to this equation because it would make one of our arguments negative, and we can't have that. Okay, let's look at the next one then. The coefficients here are both 1, so we can go ahead and combine these. This is going to be the quotient rule. Log base 6 of the quotient, let's see, 3m plus 7 over m plus 4, so that whole thing is the argument, is equal to, now be careful here, we know what log base 6 of 6 is, that's 1. So I could write this whole thing as just 2, and that's fine, we could do that. Or you can leave the log, but take the 2 up. So you could write this as log base 6 of 36. Now, it's interesting is we have these two things equal to each other. And we haven't really gotten this rule yet, but eventually we'll get to a point where, remember how we had, if I have base raised to the x power equals base raised to the y power, then I can say x equals y. That was kind of one of our rules for exponents, right? If the bases are the same, then the exponents have to be equal. Same kind of thing here. If I have logs equal to each other, then the arguments have to be equal. So I can set this stuff equal to 36. Now without that rule, we just simplify this down to 2, and we convert like we did over here. 6 to the 2, which is 36, equals the argument. And again, that's the same as if I had set these two arguments equal to each other. So one way or another, we have 36 equals 3m plus 7 over m plus 4. All right. And now we just need to solve that. We can, I guess the easiest thing would be to multiply both sides. So, cross multiply, essentially think of it as a proportion. So we have 36m plus 36 times 4, that's 144. And that's equal to 3m plus 7. Let's see, let's move the 3m over. We get, sort of running out of space here, that would be 33m equals, and let's move the negative 144 over. That gives us, I think, what, negative 137. And so m would be equal to negative 137 over 33. And let's think about putting that back into the original. Oh, clearly, right, that's going to give us a problem. That's going to make this thing negative, also make this thing negative. But all you got to do is find one in which it fails. And so this does not work, right? It's not equal. We can't use that. And so in this case, we want to say, oh, there is no solution to this one. Okay? So don't just cross this one out in this case. I mean, in this case, we have one solution. Cross this one out. This one works. This one doesn't work. But then one last little minor detail is, okay, then say there's no solution by putting this. Okay? All right. So sometimes, we're going to be using these rules in one direction or the other. So if you're evaluating it, you just have to look at what they're giving to us and which way we want to use, to do it. So if it says take multiple logarithms and write it as one logarithm, then you're using these things in that direction, right? It just depends. If they give us sort of starting values like this was, then you take this and you break it up into a smaller component. So you use it in reverse, okay? All right, so this is the homework down in here. Sorry, I kind of got obliterated by our problem there. That's the homework that is due next class.